Cool. Right. Well, I suppose firstly, thanks for turning up to the graveyard shift. I will try not to send you to sleep at the end of the day, but cool. So what I thought I'd talk about today is something that's been, I've been a bit obsessed with over the past kind of year and stuff in terms of, how we use OpenAI and LLMs and stuff, for various purposes within the organization and stuff. And specifically, I'm going to talk around something called grounding, which is kind of how you kind of inject your own data into these LLMs and use them and stuff around that. So I suppose a bit about me. I'm currently the Avanade UK and I Data Platform Director. My replacement is over there for the next week. I'm launching my own business in April, so if you're interested in that, come and talk to me and stuff, but exciting times. 20-odd years, data and AI, all that sort of stuff, mainly been Microsoft, Databricks over the last few years. Very much, I suppose other than OpenAI, Microsoft Fabric has been a big topic of mine. I've been talking to lots of clients over the past year about Microsoft Fabric and data platforms in general, so if you want me to bore you around that, then come and find me tonight, especially after a couple of beers. I can go through that type of stuff. And I haven't done SQL bits for a while. I think I did it about 5 years ago, talking about Cosmos DB and things like that. Obviously, kids and things, but obviously, with launching my own business, I've started to get slightly more active in the community again and stuff. And I've got my LinkedIn thing there, my Medium, and please feedback around this. So I suppose unless you're like this guy, you probably had a slightly less good experience than a lot of people we can see out here. Last time he flew, and he'd been on some sort of desert island. I assume you've heard of ChatGPT and what it is. Obviously landed last a year ago in November, and I think I kind of first looked at it in around about December, and it's not often you see something you think is going to completely change the world in terms of a bit of technology and stuff. And obviously since then, apart from obviously Mark Zuckerberg taking a bit of a stab at Elon Musk recently with Threads, it was by far the fastest growing application to 100 million users, and you can see by some of those figures it's virtually doubled since, and already is probably one of the most valuable companies in the world, and I'm sure it will continue to be one of the most influential companies in the world. And I won't go into all of the Microsoft element in that, but obviously some of you kind of know that type of stuff. So I suppose with something like this that looks like magic, and obviously is magic, I'm sure all of you have kind of used it in some sort of aspect, rather through Copilot or ChatGPT and stuff like that. It's always good to try and get a bit of an understanding of how does this work underneath. I'm by no means claiming I'm clever enough to understand the geniuses who built this type of stuff. But if we kind of look at it in my simple mind, you kind of start with a bunch of content, which is pretty much the internet. So Microsoft funded this. You've got everything Bing has crawled over the past. So kind of all of that text content that sits on the internet. And then alongside that, they also put in a lot more structured content, because there's obviously lots of good content, but there's obviously lots of kind of quite unstructured, not great content on the thing. So they kind of fed in some training sets that specific to areas and stuff like that. So basically what that gives you is a load of text. So we can see there SQL bits is great. And the first thing they need to do is convert that into something a machine can understand, which are these things called tokens. And tokens are quite an important thing to understand, because that's how they charge for all of this type of stuff. So the number of tokens you're passing in and coming out. And at the moment, despite it's got a lot cheaper since it came out, it's still quite an expensive technology to do. To train these things takes mega money, and to use them takes huge amounts of compute and stuff. So if you want to start using these within your organization, you really need to start thinking about how you use them efficiently, and that's what I'll talk about a bit today and stuff. But basically, when it's converted those into the numbers, it passes it into this neural network type model, which, from my kind of understanding it, there's a really good video of these puppies kind of running around a room that sort of visualizes how a computer works with a kind of neural network. But basically, it pulls out a bunch of parameters across a number of layers to optimize it, and just does trial and error, trying to kind of match a training set against a test set to kind of get a forecast of that particular thing. And in ChatGPT's case, or ChatGPT 3.5, which is the previous version that they have actually published how they did it, GPT-4 is a bit more top secret, they did that on massive scale. So they have 500 billion of these tokens passed in. They had 175 billion of those dots across 96 layers to a ridiculously big neural network that did that. And I think GPT-4 it cost something like 700 million in compute power to just train it and stuff. And once they've done that, they then go through a couple of cycles of kind of human reinforcement on top of that. So they get people kind of checking the outputs, making sure that what the output is, as kind of Scott alluded to at the moment, there's a lot of bad content on the internet, so they kind of use that step to try and kind of remove a lot of that bad content and stuff and make it produce a lot better. And then proximal policy optimization, again, I'm not going to claim to understand that, but I think it's kind of taking that and then optimizing further based on that knowledge and stuff. So what you end up with at the end is this ChatGPT type model or a large language model that comes out of it. So if I like to think of what a large language model is I think it's a bit like a bionic goldfish that's been given this mega brain and to understand everything on the internet. And one of the great things about ChatGPT is you can generate these cool images now just based on what you think. So obviously, because it's had all of that data fed into it to train it, it only knows what it's been trained up to. So the latest version is 24th of January, 2024, I think. It might have updated since I did these slides in that GPT-4. So anything after that date, it doesn't know anything about in terms of things. It can't. It can't really think for itself. I think I heard this analogy the other day of, as humans, if you ask us what is 2 + 2, we instantly say 4, because that's an instant reaction. If you ask us a more complicated question, how do you solve world peace, we would reason and we would try and break it down into problems and stuff. By default, an LLM does that first thing for everything. So you give it a massive bit of text, it instantly predicts and guesses what that next bit of text should be and the thing. And kind of that kind of helped me get my head around kind of how this type of stuff works. And by default, despite from when you use something like ChatGPT or other chatbots, there is an illusion it keeps context. By default, it has no context at all. You send it a question and send it another question, it will have no idea of what you've asked it before. It's just taking in a string of words and predicting what those string of words are coming back. So you have to give it that information as context as it goes through. So, as I said, doesn't know anything about recent events. It can't know anything about your internal company data unless it was on the internet and called by Bing. And as you've probably all heard of, it makes stuff up, it hallucinates, it just suggests that thing. If there's not a correct answer, it will give you the nearest thing to that correct answer. And there's obviously ways around that and stuff. So how do we get around those limitations of that base model and stuff of needing instruction? It forgets instantly, and there's no recent or internal knowledge in there. So how do we start to kind of use it usefully with that information? So look at ChatGPT. Hopefully you can read this. It looks a bit faded on there. If you ask a question, why is SQL bits so great? You'll get a fairly standard response. So it obviously knows about SQL bits. That's in Bing. It gives you a nice detailed, correct description of what SQL bits is and all that type of stuff. So the first thing you do, which is, if you've seen custom GTPs and things like that, is you want to give it some instruction to behave in a certain way. So as a really simple example of that, you can give it something called a system prompt. So that kind of sets its initial context up of, in this case, you know the enthusiastic salesman for SQL bits. And you can also do this thing with output prompts. So I've done quite a simple example there. Give me a short answer that will appear nicely on this slide of 15 words or less. But that's where you can get really quite powerful. So if you want to start hooking things together, you can define quite detailed JSON structures to return, or you could do all sorts of stuff with that type of thing. So again, it's kind of thinking about really giving it detailed instructions. And despite it's this mega brain, it's actually quite stupid. You really need to tell it exactly what you need to do in terms of how it comes across. So when we do that, it's the ultimate SQL fiesta where data dreams and tech magic come alive, join us. So these are obviously on my slides, but these are real responses that it gave me when I did this and stuff. So we've managed to kind of tailor it a bit more. So if we didn't have the magic of ChatGPT around it, and we then asked it another question, what is scheduled for the first day? By default in that LLM, you would get something like this. Please, could you clarify what event or schedule you're referring to on the first day? And that's because it has no clue about the fact you've just asked it about SQL bits, because you've asked another question. We just sent something to that thing. So how does ChatGPT create that illusion of doing that type of thing? And the way it does that is by storing that context of what you talked about before. So that, in its simplest form, could be just that exact conversation as text, or there's other techniques of how you might want to summarize that down and stuff. You can use vector databases, all sorts of techniques to do that type of thing to minimize what that context window is. And it feeds it in. So when I ask that second question, it will feed in that context plus the question, so it can answer that in the context of what I'm doing. And that's what ChatGPT is doing behind the scenes and most other bots that you're looking at in terms of the thing. So with that, I've then got the next problem, which is no recent or internal knowledge. So as an AI developed by OpenAI, I don't have a real-time access to current events, which is a fairly standard response it gives you when you ask it that type of thing. So the way it gets around that is something called retrieval, which is kind of what I'm going to talk about today. So in this case, it fires off a function that goes and does a web search. So it will create that search query automatically using an LLM. It will go and find the SQL web page. It returns that text from that web page. So you've now got all of that text stuck on that prompt as well with everything else. And then it will answer you that question based on that thing. And this is RAG, or retrieval augmented generation, I think if I got that right, that is the secret to how you use this type of thing within your organization and stuff. And I've used an example there of a web retriever, which is obviously pretty useful. There's lots of information on the web. But you can think of that as any kind of data source theoretically. It could be a graph, an area I'm really kind of a bit obsessed about is how you do this type of stuff on top of your metadata across your organization, all that sort of stuff. And if you want to talk to me about that, then come and talk to me. But once we've done that, it can then get that information, and it gives me a better response given what happened on that first day of SQL bits and stuff. So cool. So that's kind of pretty much ChatGPT and how that works. So the last problem there is the no internal knowledge bit. And this is where we've got this retrieval augmented generation pattern that there's lots of examples of. But this diagram here is kind of Microsoft's standard architecture of what a RAG pattern looks like. And just to walk through this quickly, you've got some sort of app. So maybe that's an app or a website. That goes across to some sort of web service. So that could be Docker image, it could be ASP.NET, etc. In Azure, which then calls into the APIs that give you access to that LLM. So in the Azure world, there's two ways of doing that. You can go direct to OpenAI, call their APIs. So actually underneath, that's still in Azure. It's still, if you pay for the enterprise or Teams version, still quite a kind of dedicated-ish instance. It's not going to be training the data like the free version and stuff like that. But if you want your own version within your own tenant, you can spin up something called Azure OpenAI, which is kind of, it's not your own dedicated thing because they couldn't possibly replicate the GCP4 model across everyone's things, but it's a secured, ring-fenced service within Azure that you sit within your region that you can call. So the app will be sending these requests and we'll get a response from the LLMs. And then to do this retrieval bit, there are numerous ways to do this, and I've got the next slide that kind of shows some other options. But I think a really great place to start in Azure is Azure AI Search. This isn't a new service. It's been around for a long time. And the great thing about this is you can stick it on top of your documents. You can stick it on top of your databases, all sorts of stuff like that, and get a pretty good solution doing this type of stuff just out of the box, which is great. And I'll show you a demo of that at the end and stuff. And so if we kind of look at Azure AI Search in a bit more detail, it's had some enhancements in the last kind of year or so, to link in with all this hype around the stuff. So as a kind of default, this is quite a simplified way of doing it, and these are actually Microsoft slides I've kind of used for this. But if we're looking, I don't know if you can see the actual bits in the blue boxes there, but if you're doing a basic keyword search, then Azure Search will find those keywords in your documents. It will return those keywords if it finds them. Maybe it has some sort of natural language processing to find synonyms and things like that, but generally it's doing that keyword search across those documents. So that's great for quite specific queries. So if you're looking for someone's email address or you're looking for a product code and things like that, and that is still very relevant to kind of find that information. What Microsoft have recently released into Azure AI Search is this concept of vector searches or vector databases. And the way these work is, in this picture, it's an incredibly simplified view. But if you have, say, 2 sentences, so in here, a lion roared loudly, and the king of the jungle made a thunderous sound. As humans, we can tell those things are quite similar semantically in terms of the thing, so they should be quite close together. So how a machine does that is represents those numbers as vectors, so strings of numbers, and it, using a vector embedding model, creates those vectors in a certain way that you can compare them, so the closer the numbers are, the closer they semantically mean together. So basically on here, you can see we've got a 2-dimensional matrix, and we're plotting those things on those 2 dimensions. As humans, we could probably look at that in 3 dimensions. Maybe we could stretch to 4. I don't know how you draw it, but what a typical LLM model would do is do this on about 1,000 or 1,500 dimensions. So it plots in this multi-dimensional space. This bit of text is really close to this bit of text, and then it picks it back out. So it's quite mind-boggling sort of numbers of how it does that type of thing. So vector search is great for that type of searching of the thing, and then keyword search is still great for the other thing. So what Microsoft also have now is this thing called hybrid search. So that searches both ways, combines the results and returns the results. You kind of get the best of both worlds, which is great, which you don't get with a lot of other kind of vector databases out of the box. And then they also add a 3rd layer on top of that. So they've got this thing called a semantic ranker that's kind of been built out with Bing search over the years. And that uses similar kind of AI-type models underneath to rank those bits of text to how semantically close they are to the thing. So you get the ones that are better. So you kind of get these 3 things working together to get you a good response, which is probably a lot better over what you get for other things. So there's obviously, with the hype that's happened over the past year, there are huge amounts of alternatives being sprung up in this space. And this diagram, again, my text's probably a bit unclear, but the top row is kind of all the open source type offerings around there. The bottom row is all the commercial type offerings. And then the first column is where you've got dedicated vector databases that just do that right-hand side of the vector database bit. And then probably, I think, where might actually get more traction in the future is where you've got databases that already do your transactional type database type stuff, and then they're adding that vector support alongside. So if you've got scenarios where you've got some of this unstructured data already in that database, you can start adding that vector support on top and then start to do slightly more powerful scenarios with this retrieval type patterns and things. I suppose to pick out a few, if you want to start with something quite simple in an open source world, the phase, I don't know if I pronounced that properly, was one built by Facebook. You can literally spin it up with a little Python library in your notebook and use it and everything like that. That's a great one. In the Microsoft world, as I said, Azure AI Search is great as a starting point, but there's a couple of other options. So you've got Cosmos DB with the MongoDB in there. So they've added vector support in there. So you've got a load of data in Cosmos DB. You can use that. You've got Azure Data Explorer, and the CustoDB now in Fabric has vector support. I think there was a talk I went to earlier in the week that talked a little bit about that. But that's quite interesting to me. I haven't really had a chance to look at it yet, but you could start to actually tie that in with the real-time scenarios and real-time analytics and all that type of stuff, which could be quite cool in Fabric. And then, obviously, if you went to the keynote, they announced SQL, so I quickly stuck SQL on there. So again, lots of this support's coming out. So if we kind of dig down slightly further into what's going on with these vector embeddings, kind of as I've already kind of explained, embeddings are numerical representations of real-world objects and concepts expressed as a vector. So that's kind of the official definition I found. And everything I talked about so far has been text type based, so doing this with text. But actually where vectors were originally invented, well before LLMs came out, was more around other forms of unstructured data like images and audio and video and stuff like that. So if you want to compare, like, the image search that happens in Windows, we'll have a vector database type thing underneath it to find images that are the closest. So you can represent all of these types of data as similar things in terms of vectors. So what you do is pass it through a special type of model that's very like an LLM, but it's not. It's a different type. It's not the same model that serves that ChatGPT, but it's called an embedding transformer model that will turn those things into a string of numbers. So I've got a page of a document. I feed it through that model. If I'm using that top one, which is called text embedding ADA002, which is probably the most commonly one used at the moment, it will turn it into just over 1,500 numbers. So that bit of text will be those 1,500 numbers in terms of that. With those numbers, what you need to think about is the more numbers you've got, the more accurate it will be in terms of how that semantically meaning is, but also the more compute you need to create it, and also the more compute you need to actually search for it and compare it, which I'll talk about in a minute. So there's lots of alternatives coming out now. So OpenAI have released one called the Text Embedding 3 Large and Text Embedding 3 Small, which large is kind of about double the size of the thing, so it goes up to about 3,000, and then small has a number of different options going right down to about 256 dimensions, I think. So you can play around with, depending on your use case, which ones you use and try and get that balance between accuracy versus cost and speed in terms of doing it. So once we kind of created those embeddings, we then have our app, i.e. our ChatGPT or something like that, and that will do the same thing. So when you give it a question, it passes it through that embedding model. It's important, it's the same embedding model. Those strings of numbers mean nothing outside of that embedding model. You can't really reverse engineer them, not as far as I know anyway. So it creates those two sets of numbers, and then it compares them. And there's various ways of doing this, and all of these vector database vendors are coming up with cleverer and cleverer ways of doing this in a much more efficient way, but generally use this thing called approximate nearest neighbor type search, which is generally just going through an algorithm to compare all those numbers, how close they are, side by side. And once it's found the closest ones, it returns those results. So importantly, it's not returning the vectors, because they're not really meaningful to the app. It returns the actual bit of text that you've got. So you need to keep that bit of text alongside the vector to do that. And then, like we talked about before, that text will be passed in as your grounding context alongside other stuff to then answer the particular question that they've asked. Make sense? Cool. So that's all kind of fine if you've got small documents or small bits of data. But what if you've got really big documents, so a 1,000-page document? So there's a couple of problems with that. One, all of these models currently have a max input of 8,991 tokens, which is approximately the same amount in words. It's not exactly words, but it's virtually, you can think of it like that. So you couldn't fit a 1,000-page thing into that 8,191 things. And then also, if you did if you could do that 1,000 pages into a vector, it would create one single vector. So if you got one set of 1,500 numbers representing that whole 1,000-page document, there's going to be lots of stuff in that document. It's going to be a very summarized view of what that document means from a semantic meaning. So what you want to do is do this technique called chunking. So, as an example, we could take that 1,000-page document, and we could chunk it up into 1,000 chunks, so one per page. And then we pass each of those chunks through that embedding model to create a vector for each of them and store them in a vector database. And that obviously then gets around that problem and gives us more specific things. So again, you need to kind of think about what the size of those chunks are, how big you want them to be. So to give you a couple of examples, if you've got a Q&A type bot with quite specific questions, with quite specific answers, you probably want quite small chunks that are maybe the questions and answers and stuff. If you're working in a legal sector, for instance, and you want to review an entire contract and ask it a number of questions, you want to make sure you've got the entire context of that contract in that thing, because you don't want to miss stuff, because it's incredibly important. So that's the kind of thinking you need to think about in terms of how you size up these chunks and things like that and stuff. And again, it's cost versus speed and all that sort of stuff. So in terms of how we do that chunking, again, it's not that clear on the screen. It's a bit faded, but I've got some text here. Obviously, there's not much text. You probably would just do this as one embedding in real life, but just as an example. A simpler way to do it is simple character splitting. So if you get a double line return, then that generally denotes a paragraph. That's probably a good place to start. You've probably got semantically meaning chunks of text that fit into paragraphs that you could split up, and we could then do each of those things as vectors. Then maybe paragraphs are too small. You want to make them slightly bigger. What you could sort of say is, right, I want a minimum token sort of size for my thing. So you split up into paragraphs and you combine them a bit together to create bigger ones. But that kind of works. But maybe you've got the second and third paragraph want to go together as an embedding, to kind of not miss some of that context as you're doing stuff. So a typical technique is something called overlapping. And if you see a lot of these text splitters, they'll have this as a parameter where you can overlap the text. So you're kind of duplicating it as you go across those vectors, but it kind of gets around that problem of kind of missing that context between two different chunks and stuff. But again, you need to kind of think of it like this. So if you're kind of pulling stuff back in this retrieval mechanism, it will only pull back those relevant chunks. It will know nothing about the rest of that document if you get this kind of chunking wrong. So it very much depends on the use case, how you do it. So that's obviously a very simple example. In terms of more advanced techniques, so there's a guy called Chase Harrington, who I think probably is going to be the first billionaire out of all this stuff, other than the guys who already work at OpenAI. Started a thing called LangChain. I don't know if any of you have heard of it, but this is an open source framework that has loads of great tooling around all of this type of stuff. If you want to get into this, I'd absolutely recommend going through some of the quick starts and documentation on LangChain. And it's moving so fast, it is ridiculous how fast they're developing this thing. As an internal resource, plus a massive community on top of it. But they've got a bunch of more specific text splitters that you can get out of the box as part of this framework. So if we're using code, we don't have paragraphs and things in code. We have classes and functions and things like that. So we want a text splitter that kind of understands that and splits it up into that type of thing. Similarly with HTML, Markdown, et cetera, or Word documents and things like that, you can use the heading tags and things like that to kind of do that type of thing. So again, you've got things already built that do that type of stuff. If you have a very custom scenario, you can kind of implement an interface in LangChain and kind of build your own one and do whatever you want. And then something I find quite interesting as well is using this idea of semantic text splitting as well. So rather than trying to text split it yourself, you can actually take that document, pass it into an LLM as a first pass, and actually ask it the best way to split it up, because it can understand the meaning and maybe it changes it and stuff. And that's quite an interesting way of doing things as well, which certainly I think will enhance over the next few years in terms of lots of people looking at that. So that's kind of splitting stuff up, but there's also lots of techniques of how you get that data back out as well, i.e. retrieval techniques. So you could do contextual headers. So in addition to those chunks of text, you can put in metadata tags around that and then include that in the embedding to kind of give it more meaning. There's this idea of parent document retrieval, and this is something in this legal, going back to a legal case again, you could have quite small vectors to get quite specific searching, but you might want to bind that to the entire contract. So you can kind of query it and get quite accurate answers, but actually the context you get back that you pass into that LLM is big. So you're kind of, you're massively duplicating the data there, but it could be useful in certain scenarios. There's kind of this idea of summary embeddings or contextual compression, which again is kind of looking at using LLMs to compress that data down. I read quite a good article on how humans need a lot more noise in text than machines do. As we read through stuff, we need a lot of stuff to kind of make it pretty, whereas machines don't need all that noise around it. They just want that, the key facts as it goes through. So you can there's lots of papers out there in terms of how you do this contextual compression and try and compress the text down to minimize the size of it before you're kind of passing it into that LLM to get information out and stuff. Multi-query retrieval is quite an interesting one. It's kind of this concept of, if you think about human teams and diverse teams, if you have a diverse team, we come at things from different perspectives and generally come up with a better solution by doing that. There's lots of research in terms of doing this with LLMs. So if you can set up an LLM, giving it a kind of role using those input instructions, and then give each of those different kind of assistants the same problem, they'll come to that solution in a slightly different way, and then it can tie them all together to get a better solution. And that's not quite retrieval, that's kind of more in the autonomous agent type space, but you can do a similar thing with queries. You can kind of ask it a question in lots of different ways and then kind of vectorize each of those to get the same response back, which could be quite a good way of doing things. And then I think as these things build up over time, time-weighted retrieval will be very important. If you've got very big knowledge stores that are being vectorized across your organization, you want the most relevant data, i.e. the most recent data first, especially if you've got contradicting data and stuff, so you can get kind of models that weight it that way. So I suppose, another thing that I haven't really got time to go into in detail is this idea of structure-aware document processing as well. And Microsoft have got something called AI document intelligence, which they've kind of used for OCR stuff, that they're now enhancing to do this structure-aware type stuff. So rather than, in the example I talked about right at the beginning with ChatGPT of extracting text from a web page, most of those just literally remove a lot of the HTML noise and then just extract the raw text out. Whereas actually, if you look at a page, especially like a complex page like BBC News or something like that, there's structure, and you kind of need to look at how that's structured and break it up based on the structure of that page. And that's something that Azure AI Document Intelligence would do, and there's a couple of papers. JP Morgan did some stuff with DocLLM around this, and then DocGraph LLM is kind of around a similar concept, but converting it into a graph shape to actually have a graph database to do that retrieval instead. But again, this is a rapidly growing field. There's a really good blog on LangChain. They've got a thing called LangGraph that of some guy who's doing this, interrogating web pages and understanding the structure, and it was incredibly clever, but in terms of pulling stuff out. So how are we doing for time? 15, cool. So very quickly, going through cost implications. So as I said, this is expensive. It's, you can easily rack up a lot of money. That's why Microsoft are limiting Copilot so much in terms of the compute, because if people use it too much, then one, they haven't got enough compute in Azure, I don't think, to actually handle the demand they've got at the moment and stuff. But the good news is it's getting better. They're getting better at building these models. Something like ChatGPT 3.5 is very much a sledgehammer approach of one massive model trying to do everything. Something like GPT-4, despite they haven't announced it, is probably something they call a multiple experts model, which is kind of multiple, kind of smaller models working together doing specific tasks. And I think that's kind of where it will go. And by doing that, you get a much more efficient way of doing this. You're not having to pass it through these billions or trillions of parameters every time you want this type of thing. But generally, as I said, they charge you for tokens. You have input tokens, you have output tokens, you have embedding tokens. So the input tokens are the text you pass in as that context. The output is what it returns to you. And the embedding tokens are the amount of tokens you're passing into that embedding model to create those vectors and stuff. in terms of there. So generally, input is cheaper than output. It depends on the model, but it's certainly going that way. And it's, it probably, if you look at there, the previous version of ChatGPT, the 32K model was 4.8p, and then the latest version, that's reduced down to 0.8p. So there are massive increments as they're making this more efficient, and I would hope that will continue. So I think this will get cheaper, but at the moment it is still quite expensive. There's also this concept of small language models out there, which are exactly the same technology, but just on a smaller scale, which are certainly interesting in edge-type scenarios, on working on your phone. I think my phone in my pocket, a Samsung S24, apparently has got a small language model in it. I don't know what it does. I haven't really noticed anything, but yeah, this is, I think we're going to see these kind of interacting with large language models in big edge networks and all that sort of stuff in the future, which could be very good. And last point on cost is embeddings. If you've got thousands of documents across your organization, think about, before embedding, creating vectors out of the whole lot, think about it. It's quite expensive to do that, and these models are updating all the time. So if you spend 100 grand embedding all your documents with ARDA 2, and then a couple of years down the line, that's then a defunct model, and you want to move to the latest 3, you'll have to do that all over again. Hopefully it'll be a bit cheaper by the time you do that, but think about that. And I think the way around that is not to kind of think of it as one big thing. Certainly with ChatGPT, you can create these custom GPTs to do little assistance. I think that's the good way to break it up within your organization as well. Kind of break up those bits of knowledge, vectorize them, stick them into almost like a microservice type pattern across your organization as you do that type of thing. So I've probably talked for far too long, but that is basically everything I wanted to talk about. So I thought I'd do a quick demo. I was originally going to do something in Fabric, but I realized I'd just be showing you Python code, which would be a bit boring. So I've kind of thought, a typical problem most of us are probably thinking after seeing all these jets is, how do I go out and buy my own private jet now? So, it's obviously a clear problem we've all got. So I'm kind of using, this is your OpenAI, which is your AI in your tenant, AI search, and then blob storage kind of thing. And what I've done is kind of pulled down a bunch of brochures off the internet about private jets. And I'm going to show you how you can quickly build one of these bots in that thing. So hopefully, where's my thing gone? I think my thing has disappeared off on the page, isn't it? Why has it gone down there? It's a bit random. Right, I'm going to have to look down there. Right, so I don't know if you can see that. Try and zoom in a bit. So what we got, pretty much just sets up simple is your environment with an OpenAI instance, a blob storage account, and one of these search instances in there. And what I kind of downloaded were a bunch of brochures. So I downloaded 3 brochures of private jets I found across the thing, which has some various details about the specifications of these private jets and stuff. And then all I did is just uploaded those 3 PDF files into a blob storage account. It's nice and simple, just upload straight into that blob storage account as we go through. My session has expired, and I'm probably going to have lost that now, aren't I? So my demo probably goes on, isn't it? Right. So when you create one of these OpenAI tenants, what you get out of the box in there are these 2 Microsoft Studio experiences. And Microsoft like to keep us guessing by changing the name of these things and bringing out new ones all the time. But what you originally got was Azure OpenAI Studio. What they've recently added is something called Azure AI Studio. They seem to do a lot of the same thing, but neither of them do exactly everything from one of them. Yeah, cool. I've played around a bit with that new one, but what I'm going to demo today is the old one. I would have thought at some point maybe this new one's going to completely replace what I'm showing you, but they're very kind of similar experiences inside it. So if we click on that, it opens up in a new window in the thing. So I'm going to maybe make that slightly bigger. So what you get in here is a number of things that you can build. So I won't show you everything in here because I haven't got time, but I suppose the important things is you have a bunch of models out of the box that you can do. So you can have the GCP4 models, you've got this text embedding model down there, you've got the GCP 3.5 ones. And what you do is create them as deployments. So you're saying, I'm deploying that model in my environment. So when you do that, you're still not paying for anything. You've just got that model there available. You only start paying for it once you use it, which is good. So you can actually set these things up and leave them there and stuff. And then what it gives you in here is a nice kind of playground type experience in here, which you can start to do it, which if you've used OpenAI custom GCPs, it's not too dissimilar to how you could do that type of thing in there. So the first thing I want to do is add my data in. So I want to create that retrieval thing. So I can click on here, add data source, and I currently get 5 different options in here. So if I've already built my Azure AI search index, I can just hook straight up to that and we're off and going, nice and simple. I'm going to show you the blob storage one. There are a couple of other options. So if you built using this Cosmos DB for MongoDB instance, indexed all of your documents in MongoDB, then you can hook this up pretty easily in there. And there's a couple of new ones I've added as well. So it looks like there's one that actually goes off to the web and searches the web, and it looks like you can actually upload your own files yourself now, rather than necessarily going through that blob storage thing. But the good thing about blob storage, once you set it up, you can just add more files in and schedule it, and it will just index them as it comes in. So if we got our blob storage, we've just got a subscription. I've chosen my storage account, which I think is right. I'll choose my container, and I will choose my search index that I want to create it, or this search service, sorry. And then I'd need to give that index a name. So I don't know, I'll just call it something imaginative like index. And you can then say, I want to schedule it once, or you don't get many options at the moment on this, once daily or hourly. And then that's kind of the standard search. You can then turn on this vector support, as I explained earlier. So when you turn that on, you can choose this model I've deployed in that thing. You have to acknowledge that's going to cost me lots of money. And you then come in and choose these 3 options I talked about on that slide earlier of, do I just want vector? Do I want vector plus keyword on its own? Or do I want all 3 of those things working together? So with the thing, so I'll go for that one. And again, I have to acknowledge that's going to cost me even more money. And and then we review and finish. I won't do that in Blue Peter style. Here's one I prepared earlier because it takes a couple of minutes just to index those documents and chunk them up and stuff. But that does automatically for you the chunking. You don't get control in here of that chunking and stuff. If you want to start to do that, you'll have to do it yourself in a notebook using something like LangChain and stuff. But this is a really nice, easy way to get started and things in there. And then we put our prompt in to do that. So if I go to your data, you can see this is my index here. If I quickly show you that. How long have I got? 5, cool. That's not going to load, is it? There we go. So this is my search index. You can see here it's taken those 3 documents, it's split them up into 12 chunks. So they weren't very big documents. So that's what it decided to do underneath. And if I search for something like plain, which hopefully will be in there somewhere, you can see it's pretty quickly returned some of those chunks across the thing. So obviously it's a really small example, but Azure AI Search is an incredibly scalable service. You can scale it up and down. You can have millions or billions of chunks in there if you wanted to. And if you can see this, you can see a few things in here, like the search score. You've got that re-ranker type score for the semantic ranking. You've got the actual bit of content in there. And then you can see here you've got that vector, which is this massive string of numbers in that thing. So if I go back here, I can then set up that prompt, so which is, oh, the screen's a bit squashed, but I've just said you're a jet salesman, use the underlying documents to answer questions about private jets. I could give it examples if I want in there to do that type of stuff and things. And I think that would appear at the bottom because I've zoomed in so much. Where's the, I need to zoom out again, I think. There we go, there's my chat. And what I can now do is start to chat in here. So if I bring up some of my things, I can ask it, right, which one is best to get some kit? And it should hopefully start to return some information. Ooh, that's not worked. Okay, let's try another one. What have I done wrong? Broken it already. Here we go. I'm a bit scared of flying. Do any have parachutes? Hopefully that's going to work. Yeah, so it's this one. It's quite cool, actually. So it's actually a private jet. The Cirrus Vision, and it doesn't have a parachute for you. It has a parachute for the entire jet. That if it's going to crash, you press a button and a massive parachute comes out and your jet floats nicely to the ground in the middle of Farnborough Airport, which is quite how the rich live. I don't know, but yeah. So very quickly, because I know I'm running out of time, what you can then do, so this is just a playground. You can't actually save anything in this playground, as I found out. I did the whole demo and it gone the next day. But what you can do is then deploy that to a couple of different places at the moment. So you've got something called Copilot Studio, and if you're familiar with Power Virtual Agents, this is the same thing, but it's now being enhanced with something called generative actions. So if you're familiar with topics and actions within kind of Power Virtual Agents to build bots, which are already quite powerful to build bots, you can now kind of make these Gen AI powered. So rather than being quite structured, they kind of almost work like autonomous agents and reason and choose the right path and all that type of stuff. And I think it's a really exciting bit of technology that I think will be massively cool to actually start to build out these agents across your business and things. But I haven't got time to show you that. So what you can do is also chuck this out as a web app. So you just kind of put in a name, you just say what you want. Again, you have to tick a checkbox to say that cost me lots of money. And what you get out of that is a nice ASP.NET web app. It's actually a React app. You can grab all of the source code. There's an open source GitHub repository with the source code in. You can just pull in and then start to customize. I've done a couple of little customizations on that just based on the environment variables on that app to change the logo and the title. But this is kind of like a ChatGPT style type interface, all within about 5-10 minutes. And that KIP option one did work before, I think. Or did it? Wait a minute, what am I doing? But yeah, you can see the history of some of the things I asked before in that web app and stuff. So yeah, that's kind of a really great way to get started of building a web app that you could probably, it's actually quite nice clean code for an example Microsoft app in terms of the thing. So you could kind of use that as a basis to then expand out and do all sorts of other stuff if you wanted around that. And very quickly, I forgot to show you, you can also click on here and view your code and create it in, what's going on there? I don't know why that's not working, but you can do sort of 4 different languages, and you can then kind of either copy and paste this into a notebook or some other thing and see that, or just look through kind of what it's doing to get an understanding of how you call these APIs and stuff to do this. But you can see it's not much code to do that chatbot. They're quite nicely wrapped up, all these APIs and things now. So, and I think that is about it. So if I just bring up the last slide. So yeah, questions, and yeah, please give me feedback. There's the link there to the thing. So cool. I think we're at time. Yeah.